So welcome back to Seen and Solved. Today, our guest is Dave Govoni, a senior chemist at Hubbard-Hall. Dave's been working with metal finishing chemistries for years, helping manufacturers fine-tune their cleaning and match finishing processes. He's known for his hands-on approach and problem-solving mindset, someone who's just as comfortable in the lab as he is on the plant floor. Stay with us. We'll be right back.
This is Molly Kellogg, President and CEO of Hubbard-Hall, and this is our podcast, Seen and Solved. In each episode, we will share practical solutions to complex surface finishing problems. Let's listen in to the latest episode.
So, Dave, I appreciate you joining us today. I know you had a long career in metal finishing and chemistry, I understand. So welcome to Hubbard-Hall and welcome to this program.
Thank you, Tim.
Yeah, we're going to talk about picking the right aqueous cleaners, which is perplexing to a lot of shop owners who maybe don't do this on a regular basis. But when we talk about choosing the right aqueous cleaner, what are some factors that these facilities, what should they be considering when they're looking for something as an aqueous cleaner?
I would say probably the first consideration would be the type of metal, obviously, that you're going to be cleaning. Another consideration would be the type of equipment that you're going to use to clean the part. For example, is it a immersion type cleaning? Is it a pressure spray type cleaning? All of those would have some bearing on what type of cleaner we would reach for. Waste treatment considerations might be another issue to deal with. And of course, what is it I'm trying to do to the part? Am I trying to degrease the part? Am I trying to remove oxides, scale, basic shop dirt? All of those would come into play when choosing some kind of a cleaner.
A lot of other considerations be pH, soil type, temperatures. All those go into the consideration as well, doesn't it?
As a rule, for example, if we're trying to degrease a part, in most cases, and I'm not going to say in all cases, but in most cases, you would move to something like a neutral, slightly alkaline, or maybe even highly alkaline cleaner for doing a degreasing application. If you're trying to descale a part, for example, or remove oxides, generally we would move somewhere in the acidic range. So the pH does play a role in how we develop cleaners and how we choose them for specific types of parts. The temperature always plays a role in cleaning. In most cases, we're running at elevated temperatures. There is a limiting factor on temperature. However, sometimes, for example, in a pressure spray wash, if you get the temperature up too high, I've actually seen cases where you can actually oil out some of the components that are giving you the low foam characteristic. So you actually can end up destroying the cleaner if the temperature is much too high. So those are some of the things that go into formulating a product for multiple purposes like this.
You mentioned earlier about soils, and I know when we say soils, broad word, but we're talking oils, flux, any type of thing. How much does that, what type of soil, what type of is on the part that will go into picking the cleaner?
For example, if we're trying to do a degreasing application, we have a whole array of different types of surfactants that we would use as components. There are also inorganic chemistry components that we can reach for that help to improve the cleaning application. There are components, for example, that can also help keep solids in suspension so that they don't reapply to the parts. So all of those things do play a role in how we come up with a cleaner formulation.
So when we talk about some of the more sensitive metals, aluminum or copper, what are the risks inherent with maybe using an alkaline cleaner with those type of metals?
Specifically aluminum, if you run aluminum with a high alkaline cleaner, doesn't even necessarily have to be a high alkaline cleaner, you can actually cause an etch on the aluminum. And if that's not the desired effect, then
it's not good if you don't need it.
Because there are instances where we've actually developed a cleaner that was able to, lightly etch in a controlled way an aluminum surface. So there are those instances where you want that to happen. With copper and even brass, running those in a high alkaline cleaner, if it's not silicated, you can end up with discoloration or even oxidation of the copper and brass. So, and the same thing applies with the aluminum. If we use a silicated cleaner, we usually can protect the aluminum from etching.
I think that's probably usually when you guys get a call saying this is what's happening, and you can probably pretty much tell right away what some of the things are going on with some of the things that you talked about, the discoloration, those type of things with that. So I'm sure you've gotten a lot of those calls over your career.
Yeah.
When you're talking about, with cleaning, I know we've always talked about your rinsing's got to be done properly right after. So, because if not, you're just going to take it down the line. Talk about that a little bit. I guess when you have a cleaner, you want to get it rinsed properly, or it won't, bother the rest of the process. Correct?
There's a number of elements to how you keep the rinses clean. One of them, for example, if you've got a multi-tank application, you want to make sure that if you're using, for example, a tunneling barrel, that you give adequate time for drainage of the solution from the parts. Just like in many plating applications, you can use a counterflow rinse to keep the final rinse that the parts see as clean as possible. Use of deionized water in some cases, depending upon, especially when you're drying parts in a heated dry type application, you may have to go to a deionized water situation. And then there are instrument applications that can aid in keeping the rinses clean, monitoring, for example, with conductivity, that type of thing.
Monitoring bath health, what a lot of people don't do on a regular basis, either through titration or the conductivity, those type of things. Talk about that a little bit and how that needs to be put into the equation when you're choosing out a new cleaner. That
I've always emphasized to a customer when we talk about doing some type of testing is that the testing that we're doing really is not looking at the entire compound or all of the elements in the product. We generally pick, in the case of the titration, we're looking at either an acid or an alkaline component, and we're measuring the level of either one of those. And we're then correlating that to the concentration of the cleaner. And that works unless you have something that might be artificially increasing or lowering those concentrations. And now the correlation doesn't really work. So it's important that we keep that in mind when we pick a titration method, for example, or even a test kit type method. There are uses of conductivity for concentration. Again, you've got to make sure that whatever you're dragging into the cleaner is not going to artificially increase or decrease the conductivity of the solution. And then, because in that regard, then your correlation doesn't really work. And one of the most important elements here is the operator. Having an operator who's paying attention, who sees oil floating on a tank that he normally wouldn't see, a change in color, all of those observations can also help in keeping, a cleaner tank operating at its best efficiency.
Probably the best tool they've got is just eyeballing it and paying attention and looking. If it doesn't look right, things to look for can really make it. I was going to ask you about things to extend the bath life. Ultrafiltration. Talk about membrane oil skimmers. What are some things that can be utilized that can help extend that?
Obviously, monitoring the bath is one of the ways that we can keep bath life as functional as possible. Another advocation that I give to customers is to take part of the bath away rather than dump the entire bath all at once. You dump a small portion of it, you replenish it, and you try to keep the concentration of the contaminants that you're bringing into the bath kind of at a stable place, so that small increases in the cleaner concentration, or small adds, I should say, and removing some of the bath on a regular basis not only will help to stabilize the bath, but it can also help in the waste treatment end of it, where you're not getting an entire bath, say 500-gallon bath coming down to waste treatment. So those are some of the things that can be done.
Let's talk about, surfactants and emulsifiers. With cleaners, what are they doing in that process? And, how are they determining, performance, rinsability, those type of things?
Well, the surfactant is basically a chemical that will reduce the surface tension between either two liquids, a liquid and a solid, or even liquid and air. So, for example, I use the analogy of a drop of water on a surface, and then next to that you put a drop of alcohol. The alcohol will actually flatten out almost completely, whereas the water forms a droplet. So the surfactants, if we were to add a small amount of surfactant to that drop of water, it actually would almost mimic what we see the alcohol doing. Now, surfactants have a dual nature. They have what we call hydrophobic or oil-loving, and they have a hydrophilic or water-loving portion. And they can also help in emulsifying oil, because the hydrophobic portion of the surfactant orients itself to the oil, and the water-loving portion toward the water. And therefore, you can allow oil and water to mix where they normally wouldn't mix. Now, an example of an emulsifier that's really not a surfactant would be mustard. Mustard is used to take oil and, when you're making a salad dressing, oil and vinegar don't mix. But if you add a little mustard there, you can actually form an emulsion and keep it pretty much stable. So those are the things that we use in many cleaners for oil removal to get us where we need to be. But a surfactant can also be just there for wetting, making water wet better.
I'll never think of salad again without thinking about aqueous cleaning. I'll tell you that. But I never heard of that analogy. But I can see where it certainly makes sense with that. Yeah. So let's talk about inhibitors and how do they prevent the flash rust, especially when we're talking on ferrous metals.
Very often, the inhibitors that we're using for example, ferrous parts, we tend to go on the alkaline side. Obviously, they can be amine type inhibitors, they can be nitrite type inhibitors, and they act at the surface to prevent the corrosion from taking place. We also use inhibitors in acid cleaners to minimize the impact on. So as we're removing oxides and we get to the base metal, we want to minimize how much attack we get on the base metal. And inhibitors will help in that regard to keep the acid, in this case, from going after the metal.
When you're talking about the defects, part defects that are mostly chemistry related, what do you see the most of those? Staining, I know we talked about that a little bit. Adhesion failures, and so talk about just what do you see the most of, and how are those solved?
Most of what I've seen is more related in the mass finishing area, where people are running parts, they don't have the right mix or the right concentrations of the cleaner, or they're not running any cleaner at all, and they end up with a residue on the part at the end after drying, and they want to know how to solve that. So that's one of the things that I see staining of parts. The technique of drying, if you're doing a hot air dry, depending upon if you're not using deionized water, we can get spots on the parts, from coming out of the drying end. And also, if you choose the wrong cleaner, you can discolor the part, in the process. So there's a lot of those considerations when you're looking for the right cleaner. And some people don't always recognize that they don't have the right cleaner. I've had that come up on a number of occasions.
So let me ask you a question. Your years of experience in the field, tell us about a cleaning challenge you saw in the field. You don't have to mention who it was, but tell us what was going on and how you all worked to solve it. I'm always curious about that, how you solve these things.
Well, this goes back a lot of years. I happened to be at Waterbury-Buckle Company, and we were brought into the vibe finishing area. And they literally gave us a pair of boots to put on. And as we walked into the room, and there were a lot of machines, they probably had 30 vibratory machines running at the same time, and they were running with a polyester resin media. And this was to basically pre-plate finish zinc die cast. And the foam on the floor was at least a foot high. And we just kind of waded through this fluff. It was kind of like a shaving cream type of stuff. And it just always stuck with me. I was still very early in my career. I didn't have a lot of experience, putting cleaners together. But it always stuck with me, that image. And I happened to be working on another process with a customer. They were doing a centrifugal disc finishing, again with polyester resin media. And I was seeing the same issue that I had seen at Waterbury-Buckle. So when I went back to the lab, I came up with a cleaner, or a compound, if you will, to run in the process that stopped that foam from occurring. And it was very successful. It's still being used today for that purpose.
So what was causing the foam? Was it the cleaner?
Well, it's the nature of the media. The media by itself, if you ran polyester media with just plain water, it'll actually form this shaving crane type foam. It's the resin that develops it's a very long lasting. You can go a month, come back, and it'll still be there. It just forms this matrix. So we created a product that prevents that from happening. So it keeps everything flowing, keeps the parts clean, because that was one of the other problems. The parts, when you go to dry the parts were completely covered with a residue, and they'd have to then subsequently clean the parts.
Anytime somebody asks you to put on boots, you're in trouble, but you probably have a solution for it, right? With that. So I appreciate you joining us. I appreciate you sharing your expertise, and I'm sure we'll talk with you soon again.
Very good.
Thank you for joining us. Our goal at Hubbard-Hall is to help you get better results with less chemistry. To hear more stories from the field, go to hubbardhall.com or wherever you stream your podcasts.